mic's supposed to be sensitive. Let me unmute Zoom now. Alright, good afternoon. Actually no, still morning. I'll just wait for 2 minutes for the timer. 12 on the dot. Start. Alright, 12 on the dot. Alright, good afternoon guys. Good afternoon students. Alright, you guys can hear me? Small chat, yes or no? Alright, excellent. Alright, yeah, thanks. Alright, so I already posted up the YouTube share, the stream. So let's start. Alright, so today we're looking at OSPF routing, lab 9.1, OSPF IPv4 routing default routes. So what we're looking at here, remember I told you I'm kind of going to be trailing because of the multiple choice in the lab exam. So this week is going to be OSPF. You will also have the labs online for the advanced routing with areas. So you should go through that lab because it may or may not involve any areas in the group project, but it's something that you should get an idea of. And EIGRP now, and that's the thing, EIGRP in the EIGRP lab, that contains pseudo, the advanced lab is actually mimicking what areas are in OSPF, but you see that a little different because it has a way where there's no areas 0 in EIGRP. You did a setup process as the EIGRP process 1 as the main one, and then everybody else has different processes connecting to the main one, but you can connect to anybody else, so that's okay. Right, so let's continue the OSPF. As usual, you could download your packet tracer file. Just remember the solution file is also there and the command file. Let me see if I could get the command file open to show you what it looks like if you don't know what it looks like. Right, let's put it up. This is what my command file solution looks like. And this is what I expect like for your group project. You would have in the end one command file. I was telling everybody about create one command file with all the devices and all the configurations required to configure them. So you see users, look at that, everything in use, even message days there, interface. Well, I even do a show just for you to view what's happening. You don't have to put it in your group project, but you could. The actual description, the interface, select the interface, the actual description, IP address, etc. And what is happening is that it's doing everything on the user's router. So I can actually copy paste all of this and paste it in my user's router and complete that component of it. Now, the reason I do this is that you do everything in one. So once you finish the one device, you finish one device. But in a group project, it might be a little different. You might have to go back and forth, but at the end of the day, whatever configurations you accumulate for that device that's what it is. So if you wipe that device, you can actually go back and type over the configurations. In the event that your backup configuration, you didn't back up the configuration, you're running config or startup is lost, that's what this is for. Right, look at that, all the network commands are there, and then some show commands, and then saving. So that's the users, and now we have the IT device, IT router. Same thing. So your group project, I'm expecting you to have a file like this, where you have all your commands in it. Yeah, no, I'm looking for that command file. If it's not there, you're going to lose marks. If I'm not that clear enough, now I am. Right, so every single device that's been configured will have it here. Now some may ask, okay, how do I edit all of this or contribute to it at the same time with your group projects? Now, in Google Docs and Office 365 Docs, you cannot edit a text file per se. I think Google Docs might convert it into a doc file before you can edit it. In terms of collaborative simultaneous editing. So some of you are using Git to upload the command files or some like the script files, that's fine, it'll work, but for everybody to edit at the same time, that would not be possible with Git. You'll have to actually check out the file, make changes, and check it back in. And while it's checked out, nobody can actually make changes. They could fork it, make a new branch, but then you had to merge that, and that's a whole complicated thing. It's not real time, it's difficult to manage, right? So that's why you'll want to collaborate at the same time. Now, the only way I'm seeing that being done in Word and Google Docs, or Office 365 and Google Docs, is to actually create a Word document, and you literally copy paste all of this in your Word document, and make the changes. Can I go straight from the cloud? Let me see if I could do a cloud. One of my browsers here. If I can demonstrate it to you. I should have these sessions, and I may or may not. Let's find out. If it's taking too long, I wouldn't bother. Copilot. Digressing a bit here. It's just taking too long. Alright, just wasting time. Alright, I'm gonna waste time doing this. Alright, so I'll leave it up to you guys to figure this one out. It's not rocket science, and it's not even computer science. It's simple, not even IT. It's just administrative. Figure it out, it's formatting it's used to work with, that's it. Alright? So I'll leave you guys to work on that. Alright, so moving on. Same thing, net card account. Right, so this is our network layout. It's similar to the RIP. It's just that I added some extra, one extra connection, I think. Is it? Yeah. Instead of intermediate 02, going straight to IT, I kind of jump it, there's intermediate 03 in between here as well, so there's additional hop going on. So it kind of changes up the dynamics a little bit, but not much. And we're going to make our changes from there. Let's go to our packet tracer and we'll see the same thing. Right, so you go to packet tracer file and get to there. Right, normal things, ISP, internet server, and DNS server, all these are set up, so I expect you guys to have this in your group projects and stuff. Right, and then define main networks. So that is the reason why I created these tables. You have you create these tables, because you need to plan out what your network sizes are. Plenty times people don't understand what the sizes are, they ask questions, plan, what occurs, what is planned, nobody knows the number, they give the estimates. As a matter of fact, we're doing a project recently where we updating and making some specialized VLANs for wireless and for the halls, and we're saying, okay, what's the network size? And we're saying, well, we don't know how much students might be there. We say, okay, for the halls, might be about 500, right? And that might just be for one area. So we look at 500 hosts, right? And we're going to have to do subnetting to handle that 500 hosts, especially with our dates, we serve on these in the IPs, and our routing has to be configured accordingly. So in our example here, and that's where I put something larger than this typical /24. The 625 host is bigger than a regular /20, or even a /23. And that's the reason why I put 625, because when you go when you're able to go on SuperNet or use subnets at that large, it's very easy now to scale it up, double that, triple that, or maybe go to 10,000, the hosts and stuff like that, right? So that's the reason why I did it like this. And the reason why I put these 50 hosts is because I broke it up into smaller pieces that we're going to use something called variable length subnet mask. Now, you guys would have seen this in some of my slides, some of my earlier slides, you'd see it. You'd have seen it in some of the workbook that I would have put on in the beginning of the course. Right, so something called variable length subnet mask. And what we're doing is that we're taking a class A network in this example, and we're going to break this down into smaller pieces. Because the subnet mask for this class then is going to be variable lengths, one for each of these different networks, different lengths, and that's where it's a single class, but there's multiple masks being used. That's where VLS, the term VLS comes in. Right, so we're going to apply VLSM on our private network. Now, if you look ahead of the slides, there's a lot of workings going on here. And I kind of took the OSPF lab to do it instead of the RIP and stuff, because none of those were dealing with heavy VLSM stuff. RIP wasn't doing that, and I wouldn't want to focus on that. I want to get into dynamic routing working and actually working. So now we get an idea of dynamic routing, and we hit our next dynamic routing protocol that can handle VLSM onto the box. This is why I started with this one. And we're going to plan it out. So we're going to sort your network. So I normally, it's a term, something called efficiently subnetting your network is a term where you actually sort your network from the largest size to the smallest size, and we'll see how that is and how that works out. Right now in our, let's say, the campus design, because of the amount of networks we have and we cater for expansion, sometimes we don't really do efficiency subnet. We actually say, okay, this whole /24 block or a /23 block might be used for a whole lot of servers in there. And from there we subnet inside of it, and that's how we do it. So it's not a really efficiently subnetting, but it allows us for expansion later in the future. And it does work out. Sometimes we have a lot of IP blocks that are not in use. A good example is this computer lab. We're using an 81 network, and it's a /24. I'm reaching limits of the 256 people are. So how I reach 256 is because I reserve up to almost 50 to 100 IPs are reserved for servers and stuff like that, while the remainder 200, well, not even 200, 100 something remains. This lab is about, from all the way down from wall to wall, it's maybe over 150 computers. So I'm reaching the limit of the network size, of that size. So then I think we can, they were already subnetted this student lab network as a /24, sorry, not 24, /23. So so it starts from 81 and it'll go to 82 dot something, right? 82.255, that's the range. Maybe later on might happen, not yet. So it has been, this subnet has worked for the last, I'm gonna say 20 years, and in terms of expansion. So maybe later on there's another lab built and we have to use the same kind of subnet, it might grow. But anyhow, so accounting is 225 hosts, that's the largest. This number will include your IP address for your router and your gateway. Not only that, so that's word host, there's also the network address broadcasters, which we'll talk about afterwards. Marked in 50 hosts. So all of these things, when they work it out, so you have to look at, this is more to help you with the CCNA question exams, or the exam questions, is where they will say, okay, well, how much hosts I have, and then you have to cater for the gateway, default gateway that's there. And you also have to cater for network address and broadcast address. Right? And so now we have the size of this. So there's two things we have. One, we have our private network block, and then we have these sizes, and we're going to an amount of how much person uses a host, right? So now we're going to see how we're going to calculate the range of IP address used. So just from this alone, this information, you can build out your entire network. and this is what we're going to be doing, right, based on these instructions. So the first step, the accounting network, 600. So I'm going to go to the first few, hit the /30 network, and I'm going to stop there. You guys could read out the rest of it because I kind of went meticulous to every single network, point to point. But I'm going to stop there, and then I'm going to continue with the configuration, right? So for 625 hosts, that's one thing. We want to know what is the size of your network. So we go in powers of 2, and this is where you have to know your powers of 2. And you can write it out in the exam. You just write it in the tablet, the book, the scrap, whiteboard marker, whiteboard and marker they give you. They'll give you one to use. You just write that out, the range, and then you look at it and see where it fits in. So you have the 512, which we know powers of 2 is 1024. So that's 1024 is to the power 10. So as 10 bits is used, and therefore 512 is one bit less. So that's 9 bits here. Right. So when you look at it, 625 falls between it. So because it's larger than 512, we cannot use the 9 bits anymore. We have to use the 10 bits to build out our size of our network. So that's it. 224 is what we use. So we use the upper limit. To the power 10. So we're going to use 10 bits for the hosts. Right. So then we look at that. And 32 minus 10 is equal to 22 bits for the network. So we have we're just writing it out there. You kind of know it offhand. It's obvious, right? 10 plus 22 is 32. That's okay. So now we start working from there. Next step. So we kind of work out numbers. Network size is 1024. Keep that in mind. Well, that's why it's listed. We're going to use that later. Because of the 22 bits for network, look where it's going. It went to our prefix size. And that's the reason why you do that calculation. So at least have it written down. That this is where you're going to be able to make your prefix. So you're thinking that your prefix is /10. No, that's incorrect. Right? You got to work it out. The prefix is the network size. That's your prefix. So from your prefix, we're going to try and work out what is our network mask. There's a /22, so sometimes you only know the /24s and everything and below that. So now we are looking at /22. So this is how I'm showing how to use it now. They have other videos online how to do this. If that works for you, go ahead and use that. If this works for you, use this. So that's fine. The idea is that you want to be able to do subnetting fast in wherever Cisco exams that you're taking, right? So this is helping you out and this is helping your network. Now, just enough, in my case, my experience, sometimes we don't even memorize. We memorize after experience and we memorize, we end up memorizing this. So then when we deal with, I'm dealing with /28 or /27 network sizes, and from there I have to work out the table. Sometimes they build out a subnet sheet and I have to say, okay, you know what, this misses some of the information like prefix, network size, all those things. So they assume other things, but adding all that additional information makes it work faster. Something like not like hashing, but you have all your data in a table, and instead of mapping out to like a relational database, some of you guys might know about it, NoSQL. Yeah, some of you guys might remember something called NoSQL, where everything is one big giant table. All these data is there, and then you actually just run selective code to pull out certain parts, and that's what it is. So that's the table. Sometimes you kind of restrict the table and say, okay, well, you know what the prefix is, so I wouldn't have to put the mask in. Right? So you just know the prefix, forget the mask. But sometimes you don't want to waste time doing the calculation, you just drop that mask in there one time. So that's why my tables are sometimes very big and extensive. It makes it easy to find everything you need one shot. So waste time calculating. Right, so prefix mask, so as you know, 22, so we just have to put it out, right? So all this is 8, and 8, 16, and then we start to count 17, 18, 19, 20, 21, 22. That's where I put the boundary here. Right, so what's going to happen is that that's how our prefix, the bits are. So now we have to work out what really is the mask. So what we're doing is taking this boundary, which you see, which is the ones and then the zeros where the zero start, and then you can convert that into the decimal. And this is what this little grand diagram up there doing. So I didn't put the steps 1, 2, 3, 4, 5, 6, 7, 8. I hope you guys could follow from this. So what we're going to do, we're going to break this down into its respective decimal equivalent. Now remember, I'm doing this by hand, so in the exam you do by hand too. If you have calculators here, people do that chugging it. Sometimes it's faster, depends. Sometimes I put the calculator to scientific mode, and then you have to change it to bits, and then you have to change from decimal to binary, right? And that's where you have to know what you're doing. So you just add it every one, you put in a value. So you notice the gradations here, 1, 2, 4, 860, 32, 64, 128, right? You'll list it out. Every one matching is going to write it down. Simple as that. 84. There's no 2 and there's no 1. And I could have done a 0 and a plus a 0. I should have done it, but maybe this should be obvious, hopefully. So now we work on the mask as 252, but that's the third octet. Right? So that's the third octet, 252. So we know what the mask is, therefore, let me see. Right, okay, 255, 25252.0, right, that's the mask is listed here. And that's where this information comes down here, right? That was what it was used to calculate. So the next step, so we have our prefix, we have our mask, that's fine. The mask is good because we're putting that into our route information, we're going to put that into our IP addresses for hosts and stuff like that, right? So now we have to know what is our network address. Now because we start from the top, it's easy, this is easy. Network address is 10.0.0. Now, the thing about it is that that's what the network address is. Now we need to find out where is the end result, the broadcast address. And this is where it kind of gets a little complicated, so you guys may have to Google it or read other videos. But how it's calculated is that you see that remainder of the last 2 bits in that third octet. That's where we're going to use the upper limit and create that broadcast address, the upper limit of it. So what happens is that all these zeros that you see here goes to 1s. Right? So well enough, it's like almost like a wildcard mask, but a little different. So if you flip all those 1s to zeros and zeros to 1s, and you convert those into decimal equivalent, that's what you get here. That's the upper limit, that's a broadcast address. So octet 3 is just some kind of rules of thumbs. You could try to use methods to kind of figure it out, what is the size and stuff. So you have a combination of 4. So you have 2 zeros here, so that's 0, 0, 0, 1, 0, 1, 1, 0, 1, 1. These decimal equivalents, right? So then you have a range, 0, 1, 2, 3, that's 4. So that's 4 items, but because this 0 is also a number as a starting point, you include 0 there. Therefore you have the max value will be 3. 0, 1, 2, 3. That's what happened here. And then the octet 4 ranges is normally from 0s to 1 to 255. Right now, this is an interesting thing. Because of this network address is larger than a regular flash 24, I put a little note here. Therefore, 10.0.2.255 is a valid IP address in this subnet, right? Because how large it is. So this, you can actually ping this address. You can set an IP address on a client, and you will be able to actually send traffic back and forth. Not recommended, but you can do that. Right? Sometimes when you do DHCP leases, sometimes you reserve and block that out. You tell it don't lease IPs and those things. So sometimes just to be safe, because sometimes when you want to split it up on subnet, it's smaller. You want that to remain as a broadcast for Lisa/24. So you might want to use it. Right, and now we look at the IP range. The IP range now, so the reason why you want to put an IP range, and this is, I'm following what those subnet calculators use online to give you an IP range as well. So they give you network address broadcast and an IP range. The IP range is where your actual hosts are, including your gateway. So anything that falls within that range is supposed to be a valid host. So IP range is 10.0.0.1, right? So it's one more the network address, and then the last one is 10.0.3.254, which is one less than the 255. Minus 1. So that's your range of IP addresses. So we just done a counter network. What we do with those IPs, well, that's up to your plan and design. So we're going to the next network now. Right. So marketing network, 50 hosts. Right. 32 is more than 32, less than 64. So then we work out what is then we use the upper. 11 to the power 6 is give you 64, so that's 6 bits for the host. 32 minus 6 is 26 bits for the network, right? So now we have a prefix of /26. Network size of 64. We're not seeing this much, we're not going to use it here in network size. When we go into the /32s, /30 networks, the points, you're going to start to see using this more. Right, so now we start hitting our /26. And when you go by memory, right, /26 is about a 64 client size. So it's large, but still too large. It's large because most people at home might even need a 64. for their home network. They might use that as /20, 27 or even a 28, depending. Right, so now we work out our mask. So we take our prefix and we will write out the bits, everything up to 26 and everything else is zeros. So it's the boundary here. And then wherever that boundary is from 1s to 0s, we then do the calculation and you get 192. So after a while of knowing this, you'll know that 26/26 is a 192, right, in terms of a mask. Right, so this is why you have to do efficient subnetting. Not only that, but you have to start from one and then you work out to the next one. So you can't just randomly pick one and say, hey, that's my network address, that's my broadcast, and that's my range and stuff, because you want to reduce something called overlapping. So your network address in this one is 10.040. How that happened is that what happened, we took the broadcast address, which was the last IP, and then we increment that by 1 or 1 bit. Right, so what happens is that we could see the 255, so that increments by 1, so that goes to 0, right? And then the 3, which is 1 bits, so right, 0 1 1 dot whatever, right? That 3 increments to a 4, which would be a 100. Right? So let's see, that's a 1 1. When it increments, it goes to a 100. Right? And know that in the binary. So that when it increments, that next value, because it goes by the increment of it, that now becomes your network address, the next network. So you realize that as a boundary, your broadcast address ends there. The next IP address, or valid IP address, via bits, right? Not for host. The next IP address comes out there will be the network address for the next network. And that next network could either be, hopefully maybe, could be the same size, right? That could be the same size as the previous network, or it can be smaller. It cannot be larger, right? So that is the thing. It cannot be a larger network what you do, because now you're going to have something called overlapping subnets. Because a larger network is going to overlap with your previous network. And you'll ask yourself, well, how does that make a difference? Well, when you set it up in a device, you want to ask the device or tell your router, you have a network one side and you have a larger network on the other side, which could encompass the smaller network. The router will know which way to send a packet, right? Especially if somebody using those same IPs or close in the same range. They say, should I go left or right? I don't know, because its bits are telling me to go, I could go either way, which was bad for your router network, because they'll tell you there's 2 paths to get to that network, which is incorrect. It's 2 separate networks, right? That's why you have to do proper subnetting. Right, so now we have established our network address. Now we have to find, okay, well, what is our broadcast address? Right, remember I talked about the network size? That is where we're going to plug that in. So the network size, basically your where network addresses, you add that network size. And it works very well for when you have less than /24s, very small networks, it's easy to work with that. So you take your network address and add your network size to it, and then you minus 1. So that's what happened here. Right, just remember your broadcast address is normally be odd. Normally it is an odd number, and your network address is normally an even number. 0 in this case is also even. Just remember that. So it's even and then odd. So when you're working it out, and you know the good thing about that, rules out half your numbers that you can get in as an answer for, right? That's a 50-50. So once you know that as an odd number, you add the network size, realize the network size is even, so therefore it has to be a larger or smaller. And then you work it out. So if it's 64, it can either be a 65 or it can actually be 63. Chances are it might be smaller, 63. And if you look at the range, when you look at the range, you'll realize, because, so now what we're looking at is CA4 carries down, and our network range is going to be from 1, the 1 plus after network address, 1 bit more, all the way down to just 1 less than your broadcast. So it's basically 63 minus 1. Right, that's the last usable IP after this broadcast address. So now we have information for the second 50 hosts. And now, so that's clear. We move on to the next one, which is our 25 hosts. And the IP network. Again, it's less than 32, more than 16, so we use the 32. And that's the reason why I did that, because now the bits changed from 6 to 5. So it went up, so now it's a prefix on 27, so it becomes a /27. So I'm just doing that to get an idea of how your network would grow. This is where the boundary is, you work out the bits, it's 224. You'll notice that the more bigger the prefix for the network, the values for your actual mask, the values get larger and larger, tending towards 255, right? That's how it goes. Right, so your network address is, so this is the thing. What was network address before? Previous network, 4.0. Right? So what's the new one? The new one, remember I told you the boundary, it'll be 1 plus the last broadcast address. So the broadcast address for the last network, then you add 1 bit. That becomes the network address for the next network. Remember your efficiency subnetting, right? So your block is big and then you go in smaller and smaller and smaller. That's how it works. Right, so that's why we could do this. So after 60 equals 64, that becomes your network address. So the good thing about this is that your broadcast address from a previous network, your network address is more case for the next network is going to just be R1. And that makes it easy to check your table and calculate. Right? So this is a good tip for you guys when you're doing your subnetting for your group project, right? To build out your OSPF table, that's the group ones and equivalents. Whole lot of routers with interfaces in there. You can build out your point-to-point network in your table and show who's the next one, and the next one is who's the broadcast address. That's why I asked you to specifically put your broadcast and network address in those tables to make sure that they don't have any overlapping. Right, so what's our broadcast address? Is basically our network address plus the network the size of the network minus 1. So 64 plus 32. So I didn't draw any table. So 64 plus 32 gives you 96 and you minus in 1. Right, so that's 95. So 95 is our broadcast address. And now our IP range is one network address plus 1 bit. And then to the end is broadcast address minus 1 bit. That's your network range. So that's your range. So you notice some things here now it's becoming a little convoluted in terms of your network address, broadcast address. But this is the norm in a lot of environments, even this campus network. We have /28, half of 32. We don't really go smaller than that, /29. /29 is used for your internet router and ISP. So South Campus has /29 blocks of IPs. That gives us 8 IPs, one used for gateway, one is broadcast, or network address, one is broadcast, so that's done. So now we have 6 usable IPs, and out of that 6, 1 are used for gateways, or 2 in our case. Out of that 6, 2 is used for gateway, therefore we have 4 usable IPs that can be sent as public IPs to the internet. So it's a small block. The rate is $30 US a month, not bad. To get a private block with an ISP, of course you have to pay for internet too, so that's how they get the money. So that's how you can easily get an internet block coming into you. Right, now we have router and connect 1 of 6. So this is where we go down to the pointer points now. So we're looking at there are 2 hosts. So this is more focused on those group ones. It's 2 hosts, range, so therefore it's greater than 1 but less than 4. So it's 2 bits for the host, 32 minus 2 is 30 bits for the network. This is like a /30, which we know is points in most cases. Right, so we work out the mask is 252. So this is a popular one that we use. It's very easy. I'm going to expect to see a lot of that in group 1 and equivalent projects, a lot of 252 masks. Right, so the network address, ported from the previous information, builds on that. 4.96 is 1 plus the broadcast from the last one, right? So remember how we worked out the previous was 32 plus 64 plus 32 is 96, right? That literally is the network address for the new next network. So we have network address. Broadcast address is basically 96, right? Network address plus 4 size of network minus 1, right? So that's 100 minus 1 is equal to 99, so that's our broadcast address. And our IP range is down there. Right, so you're going to see a lot of these coming out. So that's where I ended out and connect 1 of 6. You guys could get a gist of how to do the rest, because the rest are all almost the same step. And everything is going by amount of 4. So 96 should take you to 100. 100 should take you to 104. Then 108, 12, and 16. Right, and that ends this whole interconnects. That's all the IPs that we deal with. So that's done. Now we set our PC IP address details. Now this is already set in terms of the lab, so you guys don't have to worry about that. Of course, in the group project, you will have to set this. So in reds, I put the routers in red here. I put them PC. Now you notice some things. I put sometimes I put the PCs in the beginning in the IP, one more than the gateway, and then close to the end. We're at 60.61. Next to the broadcast, so it kind of done at 62, but it's not 62. 63 is your broadcast for this one. Right, I did not put a broadcast address here, I did the mask, but a broadcast address here would be great if you want to be, right, I didn't put the network address and stuff, but it's about the table size, so this is what you should do. IP, I look at that, I did a 2.255 to show you that this is a valid IP and you can send traffic to it. And then you have your gateway addresses here. Right, router IP address details, these are not set. Right, so you have the router name, interface, subnet mask, network address, interface. Now the reason why I put the network address here is that we're going to be using this in our OSPF commands, and that's why it's listed there. Right, so every interface that you configure, make sure you have your network address. Now you'll notice broadcast not there. I'm not using it, right? But I'm actually going to 465. Yeah, this is the first IP, right? I'm not using broadcast address, but something that you should know in the event that it's to know your boundary of your network. So that's why it's not listed here. I'm not using it per se, but you can put that in your table. I think it's listed in the group project table, so do that. Please include. Right, more IP address details, not set. So we did the calculations before. We have our ranges. Now we put into our table. So you see all that calculation I have was all that confusion and stuff. So now it's making more sense when you start to map it to these tables. So you see some things familiar, 9790, 101, 102. Where's 104? 104 is up here, the network address is here, look at that, that's 104. This is the network. Right, so your network address is important. You need it because that's going to be used in your OSPF commands. That's why I'm listing it here. Network address, keep going down the line, 8, 12, 16, and of course ITT ISP is also listed. So, did this just crash? Oh, sorry, this PowerPoint has crashed. See if I get recovery. Right. So I have, do I have my annotations? No annotations, so I lost my annotations. That's okay. You guys got my so it didn't even save my annotations. It's awkward. Totally good. Alright, that's okay. Just saving it here again. Go again. Right, so again we have our network addresses listed, our internet as well as listed here. Right. This I leave you guys to I leave this for you guys to do on your own. Alright, I'm not going to go through all this because of essence of time, right? So you guys can do this on your own. This is as well, you guys do this on your own, right? You just do it on your own. Should I get into it? Yeah, let me try doing some things and let's get from there and then we'll work from there. I will skip out some of these. Alright, so from PC4. And this was similar what we did for the Ripple as well. Alright, so PC4, we're going to ping 10.0.4.2. This is supposed to be a valid IP, but remember this is the IP is on the marketing accounts network. 10.0.0.2. Right. So again, the same thing. So these two, one is on the accounts, one is on the marketing network. Right? So you know, this is where the boundary started. Right? We're going to get timeout and we're not going to go through all of this. So we're going to do that. I think there's the one with ping any router's IP address now. 10.0.4.65. It may not ping this one because I most likely have not set it, so we're going to go ahead. Right, so you'll get error or timeout, timeout, and timeouts and these things, right? So we're configuring IP addresses on all relevant interfaces, and that's where my command file comes in, and I might copy paste from the command file. I'll see from there. Right, users, and of course here. Right, so we do enable track interface brief. Right, now we select interface. You see nothing set here. Alright, sorry, configure it now. Gigabit. .041 192. Alright, do a shot. No shot. I'll do an exit, but let's go to the next slide now. Go straight up, right? We're going to configure the next one. Just showing the IP interface as configured and up, right? Okay, yeah, go ahead. Yeah, 0.0.1. Right, so this is, I'm going to make an error here. I was going to do 255.0, but remember this is the accounts network. You have to know the size and know your mask. Right, 252.0. Right, so let's remember this. I'm going ahead next interface. 800, right? Alright, so we already started to configure point-to-point links here. You see that 252 at the end here, that's a point-to-point link. Right, just double check, make sure it's that 10.0.4.97 right there. Track interface brief, so we got 3 of them configured. Now this has 4 interfaces, so let's have one more. Right, notice again, this is another 252 is another point-to-point link. So sometimes with IP range, you know what's happening here. Right, so we got the 4 configured. Moving on. Right, I'm gonna skip this out, so you can test on your own. Right, we're not going to do any pinging and stuff, but when you configure, can connect marketing can connect clients to the accountant. Well, actually, let me do it quick. This is a quick thing. This is for a group project. That's why I'm going to do it. So we want to see this PC0, which is where marketing network could ping on somebody in the accounting network, right? So 10.0.2.255. How I know it's the accounting network size is because that was one of them that was given an example. So let's see if this works. There we go. So pinging was not happening before, but it's happening. Why? Because we set up all the interfaces on the router IP addresses, and it's going to do what it does best, route dynamically. The router table is there. I didn't do it there, but show IP route. Right, so right now it's 1, 2 connected, and it can route between these 2. Remember I told you why the others are not listed there, even though we set the IP addresses. It's because the other interfaces are down. Let me go up here. See it down, down and down. Because of that, it's not on active state, active interface, and cannot add routing entries to it, because it's like you're going to send packets away. Once it's not there, just discard the packet. And we're looking at IT, so we're going on the right hand side. And we configure an IT. 1, 2, 3, 4 sets of commands. Pick 0, 1. Right, IT's up to the 4 network. It's like their /27 or 26. Well, we work it out, right? It was 192, we did something before 192, but we work it out, now it's 26. A small network will be a bigger mask value. Right, 252, you know, there's a point-to-point address. 800. Right, so that's done. Next one. Interface to the ISP link. 01. This one I'll be careful with. I'm seeing 01 here, but I'm showing 02 there. So let's go back to that diagram. It's saying 02, right? So check your labels. That's the reason why you want to put proper labels. So this is not 01, this is 0. Check your labels. So the procedure is correct. It's just that the diagram interface was incorrect. That's why you want to type your commands out, and that's why your assignment. You want to make sure you label your diagram. Fancy here. Track interface brief. So you can see two of them are up state, two in a down state, and it's coincidentally the route pointer points in a down state. Except this one, because we still have to configure those, right? Right, so intermediate 01 router on all interfaces. So intermediate 01, okay, 00. It's 3 interfaces, so 3 sets of commands. We're going. Intermediate wrong. IP address 10.0.4.98. Now, knowing your routers, most of these now, all is supposed to be point to point, so there should all be 252 IP addresses here. Alright, here we go, make a typo here. Alright, one more chain, one more config. Right, I just did this to demonstrate, to show if we're in the right track of what we're doing, right? So first up, gig 0 is 10.498, that's good. 0020, 10.04.109, yeah, that's good. Gig 02, 10.04.105, yeah, that's good. Right, now intermediate 02. One, gig 01. Short, right? Here's the next one. Alright, intermediate. Oh, there's only two interfaces. Alright, we're good. So then do a track interface brief. Let's see if we're correct here. So just two interfaces. One is an up, the other one is up, down, so gig 01, so we gotta troubleshoot this one. Oh no, there's intermediate 03. So these are up down, it's gig 01, that's this side, this reaction here, pointing to intermediate 3, we still have to do intermediate 3, so that's 3 interfaces in here. It's in a down state because the other side is still set up, so that's why we get one as an up. So that's the next thing when you configure in, group project wise. When you configure in, check and see who's in an up state. Naturally, if you have not reached a router that has not been configured yet, the interface on the other router might be shown a down state. Alright, so that's what you want to do. Right, so now we go into intermediate 3. Alright, that's the middle here. 3 interfaces. Gig 02, so that's this one here. One, gig 00, 0/0/0. This is the we kind of chop off here, but it's supposed to be there. Is a wrong clipping. Let's make sure this is the right one, right? Yeah, gig 00 to item. So it clipped on top, it was supposed to be this clip here. 0.0.4.252. Right, and week 01. No shot, no shot. I don't have to do no shot, no shot, but I just want to make sure I have it right. Tree interfaces, all, well, at this point, this is the last router we have to configure, so everything's supposed to be in our up state. Right, which is good. Right, so we completed the section 1 summary with the all the IP address and routers configured now in the OSPF stuff. So this is end of section 1. Anybody wants a break? Lemon break? No? You good? Anybody else out there? You want to, you good? Power through? Take a break already? Alright, so we're not taking any breaks, we're powering through, right? And don't complain, you guys are, this is hybrid, so most of you are actually at home. Or in an environment where you can take a break at any time, mostly. Right, so we're powering through. What we're going to do, we're going to create OSPF IPv4 routing entries. Now, so this is the main thing with the OSPF when you're planning it out. You're part of the planning, and that's why you have a lot of planning and tables going out there. And that's what I expect you. That's why I expect you to create that when you're doing it, because you need to make it work with you and then we work the commands. So we're going to identify the directly connected networks on each router. And remember, directly connected, and they're also enabled, right? They're also enabled. Enabled, and you're going to see is up state and all those things, right? And that's the reason why you will end up right? That's why you're always supposed to know what is if the layer 1 and 2 is running up state, and then you can see the interface. Now, a nice way to check and see if it's there is just do a show IP route. So I can go straight to users and I can do that. And this kind of like a shortcut for you. So we're seeing 10040. Look at here. Now it does the prefix, but we're not, and we have to work on some other things here, right? But let's go to something else. So let's see 10000. Look at here. And you notice we put our mask in here, but this works out with the prefix, right? So that's why you have to do the prefix, get the mask, because the mask is how you set the IP. But the device keeps it as memorized, keep it record as prefix. Right, so some ways that brings it up to human readable form for you. 1004196, that's the next one here, and then 1004100 now. So you can actually set this up in your router first and then build out your network table. So it's up to you, your choice, whichever works faster, you go ahead and make sure you get the information correct, right? So it's supposed to be 4 network interfaces going out, 4 network addresses being set up here. So we have the network addresses, and now it's broken down into wildcard masks. So this is important because we need to calculate this for the OSPF. Now, a newer version of iOS and stuff will allow a regular network mask, subnet mask to be used. So you can actually plug in a subnet mask and it will work. But for the Cisco exams, wildcard mask is required, and it's OSPF, so that will be done in Cisco exams. Right, so how we do wildcard mask? Basically, we look at our subnet mask values. We take the last one that is not 255, or sorry, the first entry is not 255. So everything is 255. We take the first non-255 entry, and then you're going to convert that. Because chances are the next entry after that should be a 0. If not, well, then you have some weird mask going on, well, weird masks, which may not be valid. Actually, equipment might not accept it. So what you're going to do, you're going to take 255 minus that mask value, and it becomes the wildcard mask. Weird enough, this thing is looking like a broadcast address as well, right? So it's kind of like a broadcast, but just remember that's only for the beginning network. As you go along, it's not going to be the same thing. You're going to have a .63 duplicated. You're going to have a .3 duplicated over and over. So it's not your broadcast address for every network. That's just only for the first one in that block. The 40, that's the first one. Everybody else is going to be an R1. Adding network size to that. That's the next broadcast, and you're going out. So that's the wildcard mask. Next wildcard mask is the 10 zeros. Right, so you see the first non-255 value, you're going to take that. And then you're going to take 255 minus that value, and then you're going to get that value should end up being, chances are the wildcard mask are odd. So there's a 3. Remember that's the third octet, so that's a 3. Everything else, basically 0 minus 255, we'll give it 255. Oh, sorry, 255 minus 0. Where is it? Yeah, 255 minus 0, that's blocking it. We'll give it 55, and that's how the mask is kind of like inverted bits. So that's what they call an inverted mask. Repeat the same thing with 252s, and we're going on lane, same thing, .3. You notice a few things here. Even though the mask has 252 in the middle of it, when you third octet, the mask, the wildcard mask is still .3. 252 is, and the mask is at the end of it, the fourth octet, and now it's still at the end is .3. So bits per bits is the same thing, where it's where you place those bits. Right, IT network, same thing. So I expect that this network address table create now. You don't have to show the calculations per se. If you want to do, go ahead, put that in your table if you want to. Right, but I'm expecting to see networks, your wildcard mask, you have subnet mask when you're making out the OSPF stuff. Right, or whatever your table you're seeing there, that's what I expect. Right, same thing in the IT, all the networks. Your intermediates are going to be all your small /30 networks. The masks are these values. Right, so that's what we're going to do. We're going to keep building up and we keep going on intermediate. So every single directly connected interface as an op state will be showing up here. Right, so now users OSPF, I'm going to configure the users router OSPF for all relevant networks interfaces, and once you finish this, that finishes users routers configuration per se. And this, you see this block here, this is this main area here. I'm more focused actually. I'm going to do that. Let's double circle that. Here it's see this block here. This is the most important block in OSPF. Alright, of all the other things we've done this before, just repeating. This is the more unique stuff in the OSPF configuration. Alright, remember all these tables, we built network, mask, and then we have area now. We're doing area 0 as everything is area 0. We're not worrying about that. Remember, areas going to be on 50 routers or something, then we start to use split up the areas. We're not doing that. In the advanced lab, we'll deal with that. So look at area 0. And now we're going to start configuring. Let me just go to the next slide, just to show you in advance. And then we start to talk about passive interface and no passive interface and stuff. This is more Cisco exam stuff, but you also don't want to advertise updates going through interfaces that every other interface. You don't want updates to happen. The event interface comes up, somebody plugs in a cable in there, and the interface comes active. You don't want OSPF updates being sent across there, right? So that's why you do this. Right, back to users. Go back. Right, we did show IP interface brief and stuff like that. Is what we didn't do is show IP route, which is what we just did. So now, config terminal, router, do a question mark here, and we did the RIPs, right? So we did the RIP before, we did OSPF, EIGRP is next, now BGP is in the one course. So in this whole 2 courses, you deal with all the protocols here. So we're doing OSPF. Process ID is basically one means process ID, right? Do not mix it up with the autonomous system number ASN for EIGRP. You can have different OSPF process IDs but they all taking part in the same area, they all belong and communicate together, right? If they have in EIGRP, if it's a different process, ASN number, they're not going to communicate one another. Right. OSPF 1. You do anything else after that? Right. So it's going to the configuration mode. Now just doing a question mark. So remember we talked about ID. Right. So we have router ID. And we can set a router ID here. In fact, we can do a loopback address. Let me just do I digress a bit. You don't have to know about it, but let me just do this. I'm going to do a loopback. Loopback. Let's call it 123. Let's call it let's do it 123. Right. So we set a loopback interface has been running, and I'm just digressing, right? I'll go resume to this, and then I do an IP address. Right? So we're not going to worry about too much of that. Now we're going to do router. OSPF 1, back into there. Right. And then we do network. .10.0.4.0 0.0.0.6.3 area 0. Right, missed something here, right? I'm going to pick that up. Okay, good. Now for me, saving time, I'm going to go to my command file. Where's our users? All the way top, right? I'm literally going to copy this and paste it into my into the router, user's router. Right. That's why I want a command file. That's why it's easy for you to keep a command file. It keeps a record of your commands you're going to use. Now you ask yourself, okay, is this correct? You can actually do a do show run. Wow. And the commands I just entered, look at them. In router already there. The four of them, copy paste into the terminal. Right, that's the reason why the command file is there. You make a mistake, you lose configurations, it's supposed to be correct, you put that in. Rule of thumb, this is for me. Those when you enter query and you have to do commands and stuff and you make changes, make sure you have a command file for that solution. Sometimes you could create a command file to undo the solution, what you call rollback. Right, so some people say in our environment, they say, okay, well, you have a solution, you have your what you call it change management, you put what the commands you need to do for the change. They ask, okay, well, what is your rollback step? Your rollback step, some people say, well, you know what, reboot the device, that's your rollback. That's sometimes not an option because you don't want to bring down services. The other rollback is to undo what you did. So sometimes you have to take that same commands and then put back what the old ones are. But you have to run that as a new set of commands. Right, so and that's why the equipment is running. So you can't change it, or you can't reboot it, right? So that's where you have your rollback commands. Our environment, we don't really do much rollback commands, but at least have your commands that you can use back in the event that something happens. I know how to make this change. Now, everybody say, yeah, you can back up the configuration and configure and reapply to the equipment. Yes, that's a more disaster recovery kind of process. If the equipment fail and you need to get it back up and running. Sometimes we keep what we call the running config as in our archives to go back to. Anyhow, so moving on. So we show what it is, it's there. Right, so now we go into passive. I can literally do lab literally from the command file here. I can do passive interface. You can do different things. Passive, like a specified interface, passive interface default. We're going to shut down and lock down every single interface now, and then we're going to no passive. Right, so just an interesting thing to let you know. The moment I do that network command, any of those commands I type there, any of these, once I type that, OSPF is already enabled. OSPF is going to start advertising that network on all available interfaces as an up state, right? If you don't want that to happen in one time, start with the passive interface default first, no passive, then network commands. That way you already start to control the traffic flow. In fact, that's how we do it sometimes with firewalls. Sometimes when you play with something called access control list and stuff, sometimes you don't make changes to the main access control list, create a new one, and then you swap them. Make you check, if it works, good, then you swap them back. So that's how you do it. Right, no passive interface, gig 00, and then gig 000. Right, end, and then show IP. Well, that's out of my commands here. Hold on, deviated from my steps, right? So you notice my command file almost the same as this, right? IP OSPF neighbor, and then more commands in here. Right, so we have some stuff with ID, look at route ID 10040. Now, weirdly enough, my loopback didn't show it, so I find that not strange my loopback not showing up here. I expect my loopback to be there. Number of LSAs, link state advertisements, right? Span, this is right, short spot first algorithm. Executed, that's the extras. IP protocols. Right, router for networks, going to send out information about these guys. These are the interfaces. You'll notice, look how much interfaces that it could have sent out to if they became active. All of these. That's why they default. Sometimes you don't know which ones. I look back 1 to 3. I just want to check out why look back. What's wrong with look back 1 to 3? I suspect it's the mask causing this problem. Technically 1 to 3 is the larger value because 10.04.101 is actually a larger value than the others, but this is 1 to 3 supposed to be bigger. So I'll find out why I did not use my loopback, and it's an up state. So additional research will deal with that later. Copy run start. Yeah, it's also the right memory as well. IT router for IP OSPF and going online. Same thing with IT. Alright, first things first. IP route. And we're going to do quad 0. Right, this is setting our default route to the ISP. 181.188.2T1.65. Right, so I did that first. So it's a static route. If I do show IP route, static here, right? We statically set this. The reason I'm setting it now is that when we start to route the OSPF IT router is going to set it default information originate. It's going to take that static route and send out as advertisements to the other routers to know where's our default gateway, right? And that's important. Right, so we're there, we just finished that, so now OSPF 1. Right, I'm just going to copy paste from my my IT commands. Actually, I could type all of these. This I should be fine. Right, all the way down to the no passive interfaces there. And if I want to make sure, do show running config. Look, it's here, passive, no, and passive is there, so you can tell if it's there already. Right, and then you're going to go default information originate. Right, so someone asks, okay, well, you know, if in the lab exam you have to figure out, oh, can you go online and check notes? No, don't check notes. You use the question mark. Read this out and see what it means. Have an idea. Contribution to default information. Distance. Did you learn this? No. Anything look familiar? Yeah. Right, that's what I expect you to do. And that's what CCIE exam in the States will expect you to do as well. Use this. They wouldn't block you from using the question mark. Heck, in the CCNA multiple choice exams, when you do the certification, you have ability to do the question mark and help and view what commands it is. So yeah, don't be afraid to use it. It's there. Don't expect it to memorize the full command all the way down to the end based on its context sensitive. Right, when you're done, you can build out your commands like this. That's fine. Right, so we're done all the way out to here, all the way down to this. So we just do some show commands, see what we get. IP OSPF neighbor, there's none, no with the adjacency being set because with the IT and the users are like they're separate by routers in between them, right? So no communication between them yet. So no neighbor adjacent. And that's the reason why that configuration was done, to show you that the others in between are not passing on information. The adjacency is only for the directly connected neighbors, right? And then they pass the information along the line. And that's why all these commands are there to show you, hey, is it working or not, right? Router ID, using the IP address of the network interface to the ISP. Actually, who's that? That's I'll check something. O2. Right. Alright, it's still using router ID is 181. Alright, that's fine. That's okay. It only happens if there's no IDs, no IP addresses on your interface on startup, then it might cause trouble, but we're good here. But it picked up something and it's going to do, it's going to use it. That's good. Right, so router information sources using this gateway, we're sending it out. The networks that we've added, all of this for is routing for that, so it's going to actually let people know how to get to these networks. Everything else passive. Maximum paths, number of areas is 1, right? So we're not going through all this. Where do you shoot external routes from? We may see this when you start to do a group project, when you start talking about retrieving. There's links online in support to do that, so you guys do that. Right, so we're done here. We're going to write memory. Copy run start is about the same thing, so it's not a problem. Right, now we start to work with the ones in between. Intermediate 0, 1. And based on the diagram, the moment intermediate 0, 1 as here starts to get configured, neighbor adjacency is going to set up here and here. Once that neighbor adjacency starts to set up, LSAs are going to be going back and forth, bouncing back. You're going to have, at this point, you're going to have a full network that can be routed out to the internet. We don't even need to worry about the other routers, 0, intermediate 2 and 3 is not worried about right now. But the purpose of this is to show you redundancy and stuff when links fail. Right, so that's why I did 0, 1. I want to reach there to the real point here, right? Right, copy in again on my command file. I think I did this already. And everything in between. Right, I can even type back in the same route to OSPF 1 is not on the C. It throw up an error. And this is something that's happening new. Neighbor adjacency loading to full, done. This is what's new in OSPF. So the next step is we did the no passive, which we have done. Mark here, yes, we've done this, we've done this, done this, done this. Let's go back to our command file and see the stream of passives, right? So you can verify that. Right, and now we start to do our show commands here. And there we are, we have neighbor ID, status full. Remember, you have designated router and others, so the others. Remember, we don't have to do this because we don't want to see it much because most of point to point. It's only if you have like about 3 or 4 routers connected together in a switch, then you have that whole kind of designated router, then you have backup designated router, and then DR others. Right, neighbor ID. And the interface that's is doing from here. So right now it's only who's this? Intermediate? Nah, it's supposed to have show more. Hold on. We'll have to check what's good. Oh, this is supposed to have more. Right, protocol is not telling much about the neighbor stuff, right? Right, let me just go to users too to make a snapshot of something. Right. Right, this is correct. His neighbor is the intermediate 01. A nice way, once you get these things working, and you can do a show IP route. I do it now. We already did one, and we're getting information being learned. So what? Remember we did a show IP route before, and we only get like correctly connected and locally connected. That's it. Now it's learning. This is the OSPF routes learning here. We're gonna learn this 1, 2, 3. The next OSPF network is learning here. So learned a few of them already. This is on the IT side, users, intermediate 01, it learned all of those. And now it learned this also this other one on the IT side. Not only that, it learned a default route. This is where the default information originates, that command we did. That is being sent out through an LSA, and it's reached this router here. Now it knows, hey, if I want to get out to anywhere else, not my network, for example, internet, use this interface, use this next hop. This is the interface and so on. Right, that's how it works. So technically, OSPF is fully working. Actually, I can ping I should be able to ping. No, I'm not doing that properly. All right, I'll have to check it out later. The domain not set yet. I wouldn't let me not go there. I'll let that time out. Will that break? Yeah. There's no domain server here. Group project, guys, I'll read it for another guy. I'm going to do 02 and same thing, copy paste, and go down the line. Command file. Look at this. I'm literally start from the neighbor. copy all of this. Okay, no, wrong one. I want my network correct. I want this. I'm going to copy that, paste it in there, and everything will be configured, right? Because the first step is enabled, then configure terminal. Well, don't know. Is it? Okay, everything went so fast. Right, enable show IP interface brief. Look at that, adjacency already been set up. Right, this is show IP interface brief here. Configure terminal, OSPF 1. Look at that, all my commands in here, done. And I just had to do some show commands just for to see what's going on. I literally pasting it in here. One neighbor set up. In fact, I could do these two at the same time. Get my two commands out there, right? IP OSPF. Look at that. Right? So that's how powerful your command files are. Right? So as I expect when you do a project, look how easy it is. Right? Just save this information, right? 6. Alright, so I have to do enable. Right, and then right. Intermediate 03. Alright, so we're done here. 02. We did all the no passive and did all the show commands and setting up adjacency. So now we're going to do 03. And I'm literally the same thing, copy pasting from my command file. This whole block here. Done. Neighbor adjacency was set up just now. See all the commands, show IP interface brief, there it is, neighbor adjacency. And the way how it works, the copy run is kind of finicky, so you may not be able to get it to work properly. Right, okay, so copy run works in this case. So I could even run my copy run as a command in there. Sometimes it don't, because I put the extra spaces. That's why you see all these extra spaces in there per new lines. That sometimes forces a new line in the system. So that forces a new line and say, okay, enter for default, and it will just go ahead and build. This is the info here. Look at that, it has other neighbors, it has 3 adjacencies, right? Well, 3 more, so it's intermediate 3. Right, 1 and then all the other connects, right? So we're done with this. And we're done with all these guys. Right. So before I continue, I just want to do basically what? Show IP route. Right, look how much this table has grown. A lot of OSPFs coming up because as we have more routers now, group project guys, that is what I'm expecting to see triple this amount because the amount of routers you set up, the amount of networks. Right, so your list is going to be large. For those when you're doing between the EIGRP and you're going to do redistribute, you might see that coming up, additional networks being redistributed through external EIGRP or something like that. You're going to see that happening. So it's going to be really large when you start to set up, especially with the well, group 1, group 2 segment, same thing. So you're going to see a lot of that happening. Right? So you notice how easy it is to do the setup? Right? Default route, we did this already, right? So we've done this already. We've done this earlier. Right, we're going to connect to the internet. So what we're going to do is in the IP route, we would have done this. We did this configure terminal, we set the IP route, and we did the default information enrichment. Now we did this is important so that you guys can know this to use in the event that you need to check it out, you guys go and do that again. And it's okay, you can type it over, it wouldn't cause any problems. If it's not there, it's going to add it. If it's there, it's just it'll accept it or overwrite, and it'll remain the same. So that's good. Right, from a PC. So I tried pinging from a router, and there was no DNS setup, but we could do it from a router. We could ping the 64. It should work. I will work it from a PC afterwards, right? 64.28.139.231 C. Success. Right? So this is packet intermediate tree. Wherever it is in the middle network is going out to IT, going out to the ISP, and going out there, and it's coming back in. It's working. So now we can take a PC and do the same thing. We'll take one of these guys out here. Take one of the PCs in the accounting network. That's the furthest from the internet, and these are the hops and stuff. I'm going to reply, right? For a few times, and then we get something similar to this. Now we get immediate, why? Because the router I did the ping on did all the MAC address ops and stuff learned across the devices, right? Remember, this is packet resetting empty. MAC address tables on the routers too. You notice there's no smart switches. Right, so if we repeat it again, it should be fine. I'm not going to worry about simulation mode at this point. We can check that later. Right, can we access 888 at this point? That's our good old DNS. Right, some time out, and now it's working again. Check it again, it's good. Right, so we're done here, and we did this, and yes, we're good. Right, DNS is working. We can get to the web server via IP, then we can hit the name, right? Of course, DNS must have this entry. So this is where Packers shows it in the group project. You will have to add those DNS entries via CLI on the equipment. And there's some pages on how to do that, so expect you guys to do that. Right, and that's PC 0. Let's go to another PC. Let's try somebody else from another network here. Let's see this. PC 2. Oh, it's a browser. Oh no, but then I'm going. Well, I'll wait for this to kind of freeze it up a bit. We'll go to the browser just now. Let's go back here. Let's ping www.3605. Right. Alright, DNS is working. We've gotten the IP resolved. Should get a reply. Yes, we're good here. Browser, and we're going to browse. That's our PC2 here. And there we go. Right? Browsing via the URL here. Should be successful, yes. Both website DNS is working. Right, check the routes on each router, show IP route, etc. And protocols. We have done the IP route and we have seen it, so we don't have to go through that already. Right, so end of section 2, we're done here. Right, testing the OSPF for IPv4 resiliency. Right, so some questions. What is the purpose of the OSPF for IPv4? Right, main thing really, it's not just easier to set up, but you don't have to do too much of rechecking your links if your link goes down. Now this is just like RIP. So as far as concerned, all the labs, they do the same purpose in terms of not just easier setup. It handles when resiliency in a much shorter time frame, right? So all of them do the same thing. So what we're doing is basically we're breaking the links along the way, and we're going to try to access the internet again, and so forth, so forth. So I'm just going to do a continuous ping, let's say PC0, right? And we're going to do a count of 10, 1,000, and right. Right, so he's going to continue pinging. Linking the backbone. Right, so what we want to do is that we're using this method to find a path. Let me save this. To see where the traffic flow is happening. So we'll go to simulation. We're going to do none. Go back, edit filters, and just add ICMP. We already care about ICMP at this point. And we're stepping through. So what is going through? Look at that. It's going through intermediate. And it's taking an extra hop. Why is it not going through between intermediate 1 and IT? Because of that link. There's a slow link, serial. And that's the reason why I intentionally put some more slow links to show you it's doing extra hops. Just to get out to the internet. Right, it went through here, coming back now. Chances are it's going to go back to that same link, or it's going to come through intermediate 02. Right, coming through intermediate 2, because the cost between those parts is the same. Same speeds, same bandwidth, and stuff like that, right? So it's doing that, that's good. So it's bouncing back and forth, and we're good. Right, so now we're gonna bring on the face using the shutdown command manually, or we could do that, right? So we know that the packet is going through, let's say, up here. So we can actually break the gig 02 between these two guys. So we're going to intermediate 01. And who we're breaking on? Link on gig 02, right? Gig 02. And we just take it off. Right, shut down, it's off. So we can go real time mode. I'm going real time because I want to demonstrate how long it takes for the right, there's the timeout, and then it's back up again. So one ping timeout happened. RIP was the same thing. Right, if you go to simulation mode, of course you break the link, so what's going to happen? It's going to go all the way there, come back. And look at that, it's only picking one link to come back. Why is it not picking the other one? Because the other one is a lower cost, serial link. So it's not going to use that. But now we're going to force it to use it. Now we can do different ways to do it. We can do it in OSPF. Let me try it again, right? So back to the time. Who was the internet guy? This one, right? Small page. Right. So the internet's working, and it's good. Right, so what we're going to do, we know the packet flows here. What we're going to do, we're going to break our next link and force it now to the serial. Now, different ways you can make it, like I said, I was going to say that if you wanted to go to the serial, you could change the cost and make that serial link a better link to go through. Those physically in the real world is not. Right, but we're going to set it up. Another way is that in the event that another link fails, so let's go into intermediate 02. And who we're going to break down is that we're going to break down the gig 00 actually. So that part is there, we're going to stop that, we're going to break that connection there. Gig 00, we're going to stop that. Gig 30, we're going to shut them down. Off. Right, it's down. Yeah, you get nearby just patching and stuff, that's okay. Right, go back here, timeout just for a second timeout, that's fine. We go to simulation mode. And now we're stepping through. And now it's using our serial link. Now if we were to break any more links on this part, there will be no destination to host, right? So we're gonna, this is what this is. We've done this. Did it work? Yes. Yes, we've done this. What other links could be taken down? You see, we'll try it and we do this again. Right, this is power dynamic routing, more advanced. So it's doing the work for us and dynamically set up change up a network. Now, for the group 1 people, you'll notice that your routers are a whole chain there. That's a chain. So if you break one link there, that whole chain is down. So we don't worry about that. We leave it like that. There's certain points where other things, you can do some breaks and it'll work, but that's leave that for group 1. Group 2 persons and equivalent groups, 2, 4, not 4, yeah. I think group 2 and 6 and stuff like that. Group 2s, because of your segments and how those routers have multiple links between them, you can break links on the way and the traffic will still flow. In my group project, when I'm testing another presentation, I will have you disconnect a link in your demo and then see what happens. Right? It's supposed to work. Right? It's supposed to traffic will flow somewhere else. So let's break one more link. 0020, let's stop him. Off. Back to CLI. Come back here. I think this is real time. No, simulation. This was simulation. Real time mode now. Now we're going to get timer. Well then, yeah, destination host unreachable. It's gone. So now this packet can't go get to the internet. Let's see where it's stopping at. Who's telling us that? Right? This router 01 is saying, hey, you know what? I cannot get. That's it. Literally a direct router. And that's what users. Show IP route. Look at that, our default gateway is gone. That's what happens. Relearned everything, realized networks are down, relearned, and look what happened here. Yes, there's a neighbor adjacency, right? There is a neighbor adjacency happening between another device, yes. But there's no information being sent to me to say that, hey, there's a possible network going on there. Right? As a matter of fact, you know, there's another thing. There's no other OSPF network being learned here. And why is that? When you look at it, when you look at how the links are broken, you see that gig 0, why didn't you learn anything about this gig 0 network between the interface and intermediate 01? Why? Because it's already directly connected. Why would it need to learn that? It knows where it is, right there, and directly connected. Same thing, look at that, intermediate 02. That gig 0, that interface went down. That is going to come off. So if you go with your users, you'll notice that 1, 2, 3 links now are up. 1, 2, 3. There's the fourth link is not there anymore. Right now, I can actually bring this back up and it'll learn just by bringing up this link. So it was intermediate 02. We did that. We shut down the interface. We could bring it back up. Who was he anyhow? Gig 00. Right there it is. Bring him back up. Right. One neighbor still. We do a show IP route. Still there. I'm supposed to do the neighbor adjacency just now. Yeah, there's a part here. Oh, simulation mode. Alright. Careful when you do this. If it's simulation mode, things don't change. Right. State up. Until you press the forward button, so you have to be careful with that. Right, there goes it. Look, initializing DR other. If you do show IP route, hasn't learned, but the link that was down is now directly connected. We are 4 directly connected. Two-way, look at that, two-way. You're going to see full coming up soon. It's taking out longer. Taking longer than RIP. Right. It's going to start DR at loading full adjacency setup. All right. Now we send analysis. So IP OSPF neighbor. All right. Full designated router on that side. What is it? 109 here. 109 became the designated router. If you do the show IP route now, there we go. All OSPF being built again, just by setting up a link. So there's our default gateway, and our traffic is flowing back as normal. Destination host unreachable. We get our timeout, and now we're back out again. Right. So this is the power of dynamic routing in this setup. So let me just go to my presentation because that's kind of wrapping it up here. Right, what are the links? We did all of this. We see simulation mode. We until all critical links in the backbone have been disabled, and that's the end of section 3. Right, now the rest of it is saving configuration. So I'll just skim through that pretty fast. I won't deal with that too much. Right, so that's with this. So this is power dynamic routing. For your group 3s and your group 4s, you are implementing what you call a tier 3 network. It's really cool because you're going to be doing dynamic routing on those perimeter routers, those edge routers. So those are the edges to your network, those are layer 3s, and you put in dynamic routing and they're going to communicate to one another, layer 3 stuff. Hope you guys start on it, or else we got to do a lot of one-to-one sessions after. Right, so that is going to allow you, in the event of a router fails, the traffic will still continue flowing, or for that matter, if a switch fails, traffic will flow through another router. And that's how that tier 2 is set up. So you have that kind of level of redundancy. And you have that scalability. Because traffic between, like, say, one device and another device, let's say in 2 different departments, but they're just 1 hop away or 2 hops away, that's it. They go up to the router and come back down. They don't have to go to the core. Once your routers are configured good bandwidth, right, you don't have to go to the core. Right, so 10 gig, and naturally 10 gig interfaces is what you're looking at for bandwidth. And it does the job. You can even do ACLs at those points as well. Right, so that's what it's supposed to be. The next evolution of the tier 3 is basically SDNs, or software defined networks. And at that SDNs, that's where you end up doing SDNs is where you literally define rules and where how that traffic will flow. And that could be every switch related can act like a router in a way. And that kind of makes the network more programmable, sometimes difficult to plot out the traffic flow. It gets more complicated, but it's easy to move our user, people move around easier. Right? So that's 3. We're done here, save this stuff. End of section 5, so we're good here. Optional, secure network router, not required, and just for you to know, not required in any group projects or labs or anything like that. You're good here. So this is optional. And we're more or less switches as well you could do. End of lab. And we're done. Just before 2. Alright. Alright guys, thank you very much for attending, and I will see you guys for your see you guys on Monday actually. Alright, and we'll see how it goes from there. Alright, bye everybody. Your practice lab exam is these labs. Your RIP labs and your advanced, that's your practice lab. All those labs are your practice. So yeah, that's what it is. It's going to be pulling from those. So that's your practice lab. If you can do those labs and make those configurations, then you're fine. Right? So no practice. Not like multiple choice. Multiple choice is to get you a scale of what the exam looks like because of backward navigation and so forth. Practice lab, you're doing the labs. So this is not like something out of the ordinary. You've done it already. Alright, so no practice lab. Yeah? Welcome. Alright, okay, that's it. See you guys. Have a good afternoon, good weekend. See you on Monday. Bye everybody. Ooh, look how fast we drop off. Alright. Stop sharing. And